or you can say the installation cost, or can say the installation cost is very important, and it should be worth to install the panel, and you should get the good amount of returns, okay, in terms of the heat. Okay, so for that the cost of solar panel or installation cost must be considered. Also you can consider over here the household, the extra point you can write down this household needs. Okay, you can write down any 3 points from this or four. I'm writing down this extra point just to know about it. So need of the or requirement of the house is very important. Otherwise, suppose in case even if the solar panel output estimation is good, and your need of the house is even more than that, then also it may not be that useful. So you have to consider the need, how much joule of energy the that person need, and how much output it is giving. So all these points are to be considered while installing the solar panel. Okay, so now we'll move towards the part D of the question. So sun releases energy as a result of the nuclear fusion. So this is a process by which the radiations are coming out, and those radiations reach the Earth's surface. State the meaning of the nuclear fusion. So there are two kinds of nuclear processes that are there. Nuclear fusion is there, nuclear fission is there. We know that nuclear fission is the something where the heavier nuclei split, okay, and the nuclear fusion is the one where the light nuclei form the heavier nuclei by the process of joining. Okay, that is nothing but the nuclear fusion. So that particular process is called as nuclear fusion. So you can write down this nuclear fusion as the forming, or you can write down the formation of the heavier nuclei by joining the lighter nuclei. So it is nothing but the formation of heavier nuclei. You can write down also example point of view. Example is forming helium atom from hydrogen. So this is one common example in this nuclear fusion. So hydrogen atoms, they join together to form the heavier nucleus. That is nothing but the nucleus of the helium. Okay, so hydrogen combine together to form the helium nucleus. So that is the example of the nuclear fusion. Okay, so I hope you understood this question. Now we are moving towards the next question. Now the question number 2, figure 4.1 shows the cross section of the double walled vacuum flask containing hot liquid. The surfaces of the two glass walls of the flask have shiny silver coating. So you can see over here, this is nothing but the made up of the glass, and there are the silver coatings, the shiny silver coatings. And here you can see this is explain why the rate of loss of the thermal energy, that is nothing but heat, to the walls of the flask by conduction is very low. So why there is we are going to do this arrangement of the silver surfaces, vacuum, all these things to prevent the heat loss, okay, by all the processes, okay, whether it is conduction or the radiation. We had already seen the process of conduction where the physically object should touch, and because there is no movement of the point of the particle from one point to another like convection, in the conduction the particles transfer the energy to the adjacent particles. So they are, we can say, they are located very close to each other, and there should be a physical touch for the process of conduction. And radiation is nothing but taking place in the form of the infrared radiations. So first question is that the first question in the part A, why the rate of loss of the thermal energy through the walls of the flask by the conduction is very low. Okay, so why there is very less heat loss by the process of the conduction. So we can write down over here the glass is used, and why the glass is used over here, because glass is a very poor conductor of the heat. Okay, we are not going to use here the metal. If metal is being used, then it may conduct the heat and there may be the heat loss, but since the glass is used and which is a very poor conductor of the heat, so the heat loss from the process of the conduction is very less. So you can write down the glass. First point, the glass is poor conductor of heat. That can be our first point. That's why the process of heat loss by the process of conduction is reduced. Okay. Another point, you can see there is a vacuum. Okay, there is a vacuum between these two silver glasses. Okay, since there is a vacuum, the process of conduction is not possible. Okay, since there are no air molecules or any particles. Okay, for the process of conduction, we need the particles. We need the particles. We need the medium. And if the medium itself is not present, then this conduction won't occur only. Okay, so you can write down over here the gap between gap between the walls as no molecules. Okay, and as there is no molecule between the two gaps, you can see over here there is a vacuum between these two surfaces. So there is no medium, and if there is no medium, then there is no process of conduction, because for process of conduction and convection we need the medium. For radiation we don't need any medium. So the glass is the reason and the cap is the reason behind no heat loss by the process of conduction. Now the second question, why the rate of loss of thermal energy, that is heat, through the wall of the flask by the radiation is very low. So why the heat loss by the radiation is also very low? You can see over here there are two surfaces. You can see here the two glass walls of the flask have shiny silver coatings. So these silver coatings play a very important role to prevent the heat loss by the radiations. Both the surfaces inside and outside are silver coated. So you can see what happens if it is silvery surface. So whatever heat is there inside, if we have a hot liquid here, hot liquid. So this silver surface inside will reflect the heat. Okay, whatever radiation it will receive, it will try to reflect all, because silver is a good reflector. Okay, and if it is acquired anyhow, the sum of the heat is acquired by it will emit the less amount of heat to the outside. Okay, so outside surface is also silver surface, so it will emit less amount of heat to the environment, because the silver surface is also the bad emitter or poor emitter. Okay, so you can write down over here the silver surface, and write down silver surface is a good reflector, so that it will reflect all the heat to the liquid only. Whatever heat it will receive, it will reflect all to the liquid, and the temperature will be maintained. Also, you can write down the silver surface. Silver surface is poor emitter. So even if it receives a small amount of heat, it will emit that small amount of heat to the environment very inefficiently. So it is very poor emitter. So this silver surface plays the very important role to prevent the heat loss by the radiation. So I hope you understood this part A. Now we will move towards the part B.